Okay, welcome back to 10th grade math algebra. Now we are going to discuss about another quadratic relations that shapes into a hyperbola. So it's a little bit different with the ellipse, but overall you will get familiar with the foci and the radius and the general form. It's almost the same with the before. So let's just discuss first about the graph. This is one type of hyperbola that we want to discuss. As you can see, the graph itself is only the curved ones, and there are so many lines with different colors, with dotted, with solid. So we will discuss that later. Where we have focus, we have vertex, and we will have conjugate axis and transverse axis. We will discuss that one by one. Hyperbola is different with ellipse. We don't use minor or major axis. Instead, we use transverse axis and conjugate axis. The transverse axis, the definition is just like you can read it. It's where the foci and where the vertex is. While conjugate axis, it is like the mirror of your hyperbolas. And the center of your hyperbola will be the intersections between the transverse axis and the conjugate axis. So before we go further with the graph, let's go to the equation first.
So here we go again with the general form of quadratic relations. So far we used this one for circle, for ellipse, and now for hyperbola. So what's the difference between ellipse and circle? If you present this kind of quadratic relations, how do you know exactly it will shape into a hyperbola? So this is it. A hyperbola, the A and the B must have different sign. It means if the A is positive, then the B must be negative, or vice versa. If the B is positive, then A will be negative. About the value, it's okay if they are the same or they are different, but the thing it is they have to have different sign. Okay, so that will shape a hyperbola. The general form of hyperbola equations, as you can see here, this will almost a little bit same with ellipse, but the difference is there is a minus or subtractions or negative here. If in ellipse it is positive, it is addition, but this one is subtraction. But we have other form of hyperbola equations, or the next one, this one. So the thing is, the general form is almost the same, but either the first one, which is this one, is positive. Let's just say this is the fractions, the x fraction. We have 4 positive sign, and the y fractions have negative signs, or the x fractions have negative signs and the y fractions have positive sign. Either way, it is hyperbola. Again, let's recall back for ellipse, both will be positive. This will be an addition. So I hope you'll get the idea what is the difference. And then next, the center will always h comma k. So we always use h comma k as the center. So let's just use the same technique as the previous one. And our x will be your x radius, and our y will be your y radius. The sign indicates the transverse axis and conjugate axis. So the difference between these two general forms shows a different orientations of your hyperbola. So if we use the first one, it means because the positive belongs to the x fractions, the transverse axis is the horizontal axis, while the conjugate axis will be the vertical one. Okay, so the positive belongs to the transverse. So while the x fractions has positive sign, it means the transverse axis will be the x axis, the horizontal axis. I hope you get the idea there. If the second one, if it is the second one, since the positive belongs to the y fraction, it means the transverse axis will be the vertical one, while the conjugate is the horizontal axis. Let's go to the example, okay, so we can understand practically about what we are going to discuss, especially about how to graph hyperbola based on this quadratic relations equation, as you can see from your screen. Now I take this example from the textbook. So this is one of the example of hyperbola equation. So you can see here that the A and the B, they have different sign. The A is positive 25, the B is negative 16. Okay, so this must be a hyperbola, not an ellipse, not a circle. And then let's go to the objective. Since we want to graph this, first you need to convert this equation into the general form of hyperbola. Now the general form of hyperbola, as we have discussed before, there are two types. There are two possibilities. Of course, at the beginning, we cannot predict which kind of final form that we will find, except that you are familiar with this. But let's just open for these two possibilities. Okay, we don't know what is the result of the last form that we will find. Whether either this is the first one or the second one. So the second objective is then we graph it. So now we will discuss how about the conversion first, and later I will discuss about the graph. This is the steps. Let's follow the steps one by one. First, since we have this equation, let me just highlight it, this equation, and I want to convert to either this or this. First, we need to change the 0 into 1, so there will be a number. So since we need a number on the right member, so I add both sides by 444. So we will have this as the result of the first step. I hope this is very easy for you to understand. The next step is I will change the order, since we need to combine all the x variables and the y variables. I will just change the order with the commutativity axiom for addition, and the result will be like this. After that, I will exclude the coefficient of the squared variables. It means the squared variables here is the x squared and the y squared. So I will exclude the 25 from the x squares and the negative 16 from the y squared. And this will be the result. Okay, don't forget, when I exclude 25, it means I divide this by 25 and negative 100x by 25. When I exclude negative 16, it means I divide this by negative 16, also this by negative 16. I hope this is clear. So yes, and then we complete the square. It means that I need to complete the square inside the parentheses. And of course, you have been trained for that. Since I add, so before there was no 4, there was no 9, but I force it to add 4 and 9 to complete the square. Since I add something on the left members, I need to add the same with the right members, but the values, be careful. First, because I add by 4, it means I have to multiply by 25 first. 4 times 25 is positive 100. And because I add by 9 on the left side and the coefficient is negative 16, I have to multiply 9 by negative 16. So I have negative 144. So I factor and simplify it. So when I factor this, it becomes like this. And when I factor this, it becomes like this. So I simplify the right member. So I did add it and subtract it. It becomes 400. Okay, up until this, I hope it's clear. Next, since I need 1 on the right member, so I need to divide all by 400 to get 1 on the right member. I divide both sides by 400. This is the result. Okay, this division, since I can cancel 25 and 400, I can cancel also 16 and 400. In the end, I will have this. Okay, so when I cancel this, I get only 16. This is 1, and then this one also. I hope this is clear. So since I need to refer back to, okay, so we have this kind of form, not the second one. We have the first one because the negative or the subtraction is on the middle and it belongs on to the y fraction. Okay, since I need to get the rx and ry, I need to convert the 16 and 25 into 4 square and 5 square. So we have this as the general form of our hyperbola, or if I want to refer to the textbook's form, we can use this kind of form as your final answer. Okay, and then in the end, we have conclusion from this final general form that this will be hyperbola, of course, and then it has center 2 comma negative 3 is the same with h comma k as before, and then it has rx 4 units and ry 5 units. And the thing about the negative, this one, which is the transverse axis is on the horizontal, since the positive belongs to the x fraction and the negative belongs to the y fraction. It means the transverse follow the positive. Since the x is the positive, so the transverse axis will be the horizontal axis and the conjugate will be the vertical one. And we will discuss this when we graph it, so stay tuned.